Hello to the Amstrad CPC community. Recently there was a very interesting discussion on the EU CPC, Amstrad CPC wiki forum, started by the user ETO or Ito, I don't know how to pronounce him or what it even means, but the discussion was about measuring the lag, the display lag introduced by devices such as this, a Scart2HDMI video converter, right? So instead of using your trusted old CTM CRT monitor, you can of course connect your beloved CPC to a modern TFT monitor, right? Using one of these devices, right? Either RGB to HDMI or Scart to HDMI, right? And I'm using this device for the last 6-7 years, and overall I'm very happy with it, right? And then I was a bit shocked when ETO measured the lag introduced by this device and said it is like 100 milliseconds, right? And of course, me being a bit skeptical in nature, I of course have to confirm or validate this claim and measure it by myself, right? And so ETO's way of measuring the lag was basically turning on an LED from the CPC using a program, right, on the printer port, and then also changing screen color, right, and recording this with a iPhone or video camera at a high frame rate, right, and then using a video editing program, analyzing the footage frame by frame and figuring out the time data between when the LED goes on in the video, right, and when the screen changes color, right, and assuming that both the LED and the screen colors have been changed at the same time, right, or with a microsecond delay, right, depending on the kind of program or whether it's basic or machine code, right. There will be some lag, of course, between those two operations, and then basically figuring out, so the time that you are measuring between those two events in the video footage should then be the lag introduced by the Scart to HDMI or RGB to HDMI converter, right? So, and I figured rather than doing this, with an LED and a video editing software and analyzing the footage, how about we measure the lag in real time, right? And to do so, I'm basically using a 2-channel oscilloscope here, right? And it has 2 channels for a reason, right? So channel 1 is used to pick up a digital signal generated by the CPC, basically ETO's LED, right? But rather than turning on an LED, we are picking up a digital signal directly from the CPC. So this is LambdaSpeak FS, and LambdaSpeak FS makes it easy to basically turn on a digital output port, right? It has a GPIO header here, which is usually used for LEDs, right? But it's just easier for me to pick up a digitally generated signal from the CPC there rather than hooking up something to the printer port, because I just have that available, right? So that's channel 1, which is going to be our square wave signal, right? And then on channel 2 you can already see a signal here, the blue line, right, which is now a photocell, right? So here's a photocell, right, a photoresistor. And so this is picking up changes in brightness of the screen, right? So when I change the color, then you'll see a signal here, and you can already see that it's picking up the 50 Hertz signal from the screen, right? And that is also, it of course depends on the brightness of the screen. So one of these squares in the oscilloscope now is 20 milliseconds, right? And you can tell that on average this signal is 20 milliseconds, right? So exactly 1 CRT frame. So now let's start that program here. So basically what that does is, it's listed here, it turns on the digital output, right, and then changes the border to white, to bright white, right? Then it waits a bit, and then it turns off, turns the border black again, and also shuts down the digital output to 0 again, right? So if we now can select the wait frequency, right, and you can tell now, you can see that there's a clean digital signal now here on the oscilloscope, the digitally generated one here, right? And at the bottom you see the the signal from the photocell, right? And you can tell here, I'm using the start and end cursor here, that on average the delay is about 25 milliseconds between, you see that dip in brightness, right? So it's between 20 and 30 milliseconds. On average it's like 25. So with that, I think it's safe to assume, and this is of course an artifact of the missing synchronization between my digitally generated signal here, right, by the basic program, right, simply a counter, and the CRT, right? So, but on average we have 25 milliseconds of delay basically between the LED turning on, right, or the digital signal, and the change in screen brightness. So 25 milliseconds for a CRT, and these 25 milliseconds are of course, I mean 20 milliseconds on average are simply caused by, you know, it takes by the position of the electron beam, because it takes 20 milliseconds for one CRT screen to be displayed, right? And so it's just random. But then another 5 milliseconds are caused simply by the basic program, right? Because there's a delay between the out statements that trigger the channel 1 digital signal and the change in border color, right? So that's another 5 millisecond delay. So this is our baseline, right? So it's safe to say it's like 5 milliseconds of delay for a CRT, right? 20 milliseconds just being caused random by the CRT electron beam position, and 5 milliseconds caused by the basic program. So how will this Scart to HDMI converter now perform in comparison, right? That's the next thing we are measuring. I've now connected the Scart to HDMI converter to my CPC, and we are good to go to make the measurement and see what kind of lag it introduces. See, I've already put the photocell looking at the border there, right? And again, the blue line here, light blue line, is a photocell. So if I change the border color, right, you will see the change in the signal, right? And now let's start our program. So given that ETO measured like 100 milliseconds or so, we should probably make sure that we run our test program really slowly, right? So that the pulse width of the square wave signal that we are generating is actually long enough, so that we do not confuse, you know, the end of the previous signal with the beginning of another one. So let's run it at 500, 5 times slower than on the CRT case where we used 100, right, and see what it does. Alright, let's zoom in a little bit here and see if we can figure out the delay from that. Okay, so yeah, indeed, this is looking much worse than the CRT case, right? Again, now, since I zoomed out a little bit here, the time scale, 1 square is now 40 milliseconds, right? And you can tell that it's 40, 80, 120 milliseconds or so until you really see a noticeable change in brightness from the photocell. So it looks like ETO was right. Not saying that I doubted him, but you know, better to double check. And that the lag introduced by the Scart to HDMI converter is really significant. We can try to set those cursors here and get a more accurate measure, right? So I can put this cursor now to here, right? And what we see then is, yeah, so where's actually, yeah, that is indeed like 120 milliseconds, right? Yeah, that's noticeable lag. It's even a little bit more on average than that, I think. Still need to put it a little bit more to the right. So yeah, pretty bad indeed. 125, 130 milliseconds of lag introduced by the Scart to HDMI converter. Huh, who would have thought that? So how does that compare to RGB to HDMI, right? And I have one more candidate, which I'm going to show you in the next segment. Stay tuned. Alright, and we have one more converter on the test bench. This time it's the HD-VC-9900 version 1.1. You can see it here. I got it from AliExpress for 35 euros, rather affordable as well. And basically it is the HDMI output only version of the well-known GBS 8220 converter, right? Which is a RGB, composite, S-video, etc. converter to VGA as well as composite, I think. So this is the first time I saw this one. This seems to be rather new. And of course the GBS 8220 is with us for a long time already. I think I saw the first videos and reviews in the retro computing scene about that one like 10 years ago. So okay, so the photocell just got moved around a bit, so let me put that back so it's picking up the signal. And what do we get here, right? So let's have a look. So the screen is not as bright as I haven't adjusted the settings, but we get a clear signal. And so what can I say? Yeah, the lag looks considerably better than with the Scart2HDMI, again confirming ETO's measurements, right? So let's get a more precise picture here by moving the end position cursor here. So it looks like this is like 65 milliseconds, right? Which would amount to about, 3 CRT frames. Now much better, almost half the time than what the Scart2HDMI converter was giving us, right? Okay, so not a bad device for this price, and I would say that the sharpness and the image quality is also pretty good. So it looks pretty sharp to me, especially on such a small screen, right? But another big advantage of this converter is that you actually can adjust the geometry, right? This is something which you cannot do with the Scart2HDMI converter. So pretty neat converter for that price, and doesn't have a terrible lag either. I think we said 65 milliseconds now, right? So the next thing would be to really measure the lag introduced by, RGB to HDMI. But I don't have an RGB to HDMI module. Honestly, it's also a bit pricey. I mean, especially if you need the analog daughter board for it, right? Then this adds a lot of costs. And sooner or later, I'm going to get an RGB to HDMI, and also going to measure the lag then. Until then, I hope you enjoyed basically this little measuring testing session, basically confirming ETO's measurements from the CPC wiki forum, right? And yeah, hope that it adds to the discussion and that it helps you to choose your HDMI solution, right? I think if you're only using, slow games, or if you're not really a gamer, right? If you are mainly using text processing and applications on the CPC, then you could be perfectly fine with the Scart2HDMI. The image quality is still, in comparison, I would say better than the image quality you get from the V9900. But, you can't control the geometry, and the lag is also much worse. So until then, take care and enjoy your CPC. Bye.